Hi guys, I'm Brad Montgomery and welcome to The Breakdown. In here we talk about science, psychology, and investing. Today, we're going to be talking about all things lightning. What causes lightning, what areas see more lightning than other areas, and all the different types of lightning that there are. Before we get started, if you missed any of our episodes, just go to kfoxtv.com/the-breakdown. Now let's break it down. And I'm here with Tim Bryce. He's a forecaster with the National Weather Service. And Tim, we're talking about all things lightning, and I know you know a ton of stuff about lightning.
I love lightning.
Yeah, we all do, from a safe distance. And we're going to be talking about safety as well with lightning as we go through here. So first of all, what is lightning? One of the more basic definitions.
Lightning is just a big electrical discharge. If you've ever walked across the carpet, shuffled across the carpet, especially like on a cold winter day, and you've reached out for a doorknob and you've got that zap, or the way I talk with kids, they slide down those plastic slides and they get to the bottom and all the hairs on their arms are standing up. That's a static discharge that's building up on their body. And then when they touch somebody or touch something, you get that static discharge. That's all that lightning is a big static discharge. What's happening inside the thunderstorm cloud is that you're getting ice crystals and raindrops rubbing together, building up this charge, and eventually has to discharge it. Most of the time it discharges itself inside the cloud, but every once in a while we get those what we call cloud-to-ground lightning strikes, and those are the ones that can be dangerous.
Yeah, those are the ones that reach all the way down to where we are, okay? And we're going to talk about different kind of aspects and types of lightning. It's going to surprise some people here what we learned today, but there's been this thing over the past several years, and I guess maybe longer, but more in the storm chasing community that started to come out, and you started hearing about positive lightning, you know, and I had kind of seen some of these videos, and I think we've had some here. It's where it's more the horizontal, gigantic car alarm setting off bolts, or is it where it goes more horizontal, or is there some kind of?
So there's actually two forms of lightning. Okay. There's positive and a negative lightning. The majority, 90% of the lightning is negative. What happens is that it's bringing negative charge down to the ground. Okay. And the positive one, it's just the opposite. It's bringing positive charge down, or it's taking negative charge up into the cloud. Usually your positive lightning strikes come out of the top, the anvil, that flat part of the thunderstorm, where the positive charges are building up. So that's where we can see those. The trick is that if you do get a positive discharge, especially a cloud-to-ground lightning strike, they last much longer. Okay. And they're much hotter. Okay. So those are the ones that can start our forest fires and things like that. The negative lightning, the regular ones that we usually get, they're dangerous as well, but for other reasons. But those positive ones can start those fires because they last. When I say last longer, it's not like they're lasting for like a minute. Right. It's still just a few tenths of a second, but it's much longer than the negative strokes.
Right. And and I'm glad you described it that way, because we had a storm. This was years ago, and on the front part of it, you had your negative, and they were, make your thunder, and not a big deal. Storm rolled through, and then on the backside, after the storm had left, there were about 5 of them, and I remember I was sitting at my computer, and I was right up the street here in some apartments, and it was festival in Mesa, and I wasn't even near the blinds. Yep. And that light filled and the blinds were closed, and the light filled the room, and I was like, what just happened? And then about 3 seconds later, boom, and you can hear car alarms going off. Yep. And that happened about 3 or 4 more times, and that was something else.
It's not uncommon with the higher terrain, with the Franklin Mountains that we have here, that you'll get positive charges off the top of the mountain because they're sticking up a little bit higher. And you can tell visually the difference between a negative and a positive charge, not in the color or anything, but the branching. Because most of the time your negative cloud-to-ground lightning strikes will have a point in the cloud, and then they kind of spread out in that branching. It's the exact opposite. You have a point near the ground, and it spreads up into the cloud like that. So there is a visual difference between them as well.
That's cool. That's interesting. So there is such thing in positive lightning.
Yep.
And I had one. So yeah, those are the ones I could see.
And we track those. We on our displays at the National Weather Service, we actually put a little minus sign for the negative ones and a little positive sign, just so we can differentiate between the two. And it is interesting. Some storms get very excited, and they're much more. They have many more positive lightning strikes than negative, and the others are all negative. So it's kind of interesting how Mother Nature kind of works that out and balances those things around.
Do they have are there any theories, like if the freezing line's a little lower, or more hail in the storm, or any theories on that?
I have never read why one storm might have more positive strokes than negative strokes, but it is something that I do think a lot of scientists have studied, because there's theories into tornado genesis associated with lightning, heavy rainfall associated with lightning. So people are always trying to understand lightning a little better and how it affects different parts of the weather around us.
Yeah, for sure. Boy, there's so much in weather that we're still like kind of coming to grips with.
Trying to figure it all
it's
out.
Awesome.
Understand. Oh yeah,
it's amazing. So okay, and I want to talk also about so most people, actually some people might know this, many people may not. Volcanic lightning. I mean, it's not just thunderstorms where you get stuff mixing around. So what is volcanic lightning? What causes that?
Well, when you get a volcanic eruption, you're spewing a lot of ash, a lot of fine rocks up into the atmosphere. And again, that starts that rubbing motion, builds up that static discharge. I was just reading an article a few days ago about the Tonga underwater volcanic eruption that we had, what was that?
Big one.
A couple years ago?
Yeah, a year and a half,
or a year and a half ago. It had such a incredible release of lightning activity. It's like 50,000 lightning strikes in 5 minutes. Just a mind-boggling amount of lightning, just from the energy and the way that all of that the ash was forced upwards, and it caused all that rubbing, just a tremendous amount of discharge that took place.
Yeah, that eruption, just seeing the satellite picture, I think it was a Saturday morning, and I woke up and I'm seeing all this stuff on Twitter, and I'm like, that happened, and then the fact that was heard all the way from Southeast Asia in Alaska. I mean, it makes you think, there's stories of Krakatoa, way back when, and these massive booms, and it's like, well, maybe some of these things you can kind of see, how far they can go. That's really, really interesting. And volcanic lightning, I guess, would pose a hazard near a volcano, but that's already a hazard in itself. It's probably the lesser of the hazards.
Right. That's probably one of the lesser ones you need to worry about. Volcanoes in and of themselves are a threat, of course, to people anywhere near the volcano, but also to aircraft. That fine pumice that it puts up into the air is not good for aircraft engines. So especially like the Weather Service Office up in Alaska, they have to issue volcanic advisories, volcanic warnings, so that the airlines can avoid certain areas and not have their planes fly through this ashy, rocky material.
That would be. I think years ago they had a plane go through it, I think. And
well, the problem that we get is over in Iceland. Iceland, of course, has a lot of volcanoes, and it's just downwind from Europe. So whenever Iceland has a big volcanic eruption, it disrupts airfare in and
Paris,
around
London.
Europe. Yeah, exactly, because they have to reroute all these planes.
Wow, it's crazy. So now, and also, let me ask you about this. This one, I'm imagining, because of it would make sense. However, I want to ask to make sure. Wildfire, pyrocumulus. Can they make lightning?
Yeah, again, same thing. With a pyrocumulus is just a thunderstorm cloud that gets formed on top of a wildfire. And what happens is that all the heat that's concentrated in these wildfires, they can actually begin to make their own weather. They draw in air from the outside, it gets heated up, and it gets rising up. And anytime you get lifting motion, you can get clouds. And if there's enough moisture in the air above this fire, you can get what we call a pyrocumulus, which is just a thunderstorm cloud above a wildfire. And then you got all that debris, all that burning stuff, all that little smoke and embers. Again, all that rubbing together will get you that lightning strikes. And of course, the people who are trying to fight those fires hate that, because that's just more lightning coming down, puts a threat to them. Also, more lightning strikes mean more potential fire starts.
And I want to say, and just a quick sidebar here, was it Northern California where they actually had like a meso pyrocumulus and a tornado warning?
It started to spin, yes. That was I think it was over by Hanford, or one of those Weather Service offices had to put out some weather warnings based on what was happening just within this large wildfire.
That's just incredible. That's crazy. So, okay, wildfire, pyrocumulus clouds can also produce lightning. And okay, now there was something, and this is kind of interesting, coming up through the 90s and on through the 2000s. And apparently, I had seen several interesting articles on this. You can find a bunch of articles on this. People don't even know about red sprites and blue jets. And what I found interesting about this, and this is one of the greatest things about more photography and more videography, I guess pilots had been seeing these
Yes.
for a while, but nobody really believed them because
or they didn't want to report them for fear of what people would say. But definitely, there are people who actually now will go out. And the trick with the sprites and the jets is that you don't want to be like near the thunderstorm. You need to be tens, dozens of miles away from it, and it's off in the distance, because what these are, we're used to lightning that comes out the bottom of the cloud, and it's not lightning that goes up out of the top of the cloud, but it is definitely an electrical discharge that goes out of the top of the cloud, and they do look like kind of like a fountain or something
it's
spurting
weird.
out the top of these clouds. So you have to be dozens of miles away from the thunderstorm. Has to be almost always at night, and you see it way over there, and you'll see, and sometimes they even have to just take pictures of it and then go back and review because it's kind of faint and dim. Sometimes you can see it with your eyes if you're watching, but most of the time they go back with their cameras and see there was one there, there's there,
Zoom in.
and they do take on different colors and things, and they have different funny names, sprites and jets and things like that associated with them. But it's definitely something that we've only recently kind of been starting to study scientifically.
Right. It's brought more in the forefront.
Yes.
And this is kind of an interesting one I want to talk about, and this is a little branch off too. This is one that also is I don't know if it's more folklore or ball lightning. Mm-hmm. What is the final consensus on? Now, ball lightning is almost like a little ball of plasma,
Yes.
that would form, and people would
Right.
see little orbs during a storm, and then
Right.
they would poof or whatever,
Exactly.
burst in their home or do weird things, go through the window, and they've kind of recreated what they think it may be in a lab.
Right.
But I've never seen, of all the stuff of blue jets, sprites, of everything else, I've never seen convincing, like
here's a picture of the ball.
yeah,
lightning.
or video. What's the
So I'm pretty sure I've read enough stories about ball lightning. Most scientists have read stories. Now, when I was growing up, they were like, this is, we're not sure if this is real or if it's fiction or anything, but I've read enough stories over the years. I've never seen ball lightning, but basically ball lightning is when you get a regular lightning strike, it really heats up the air, 50,000 degrees Fahrenheit. It's hotter than the surface of the sun. So it heats up that air and it plasmatizes some of it. And I'm not even sure if that's a real word, plasmatize, but I made it up right there. But it heats up the air so hot that it glows.
Okay.
And you end up with this little ball of energy that's glowing. And I've read, now, some of the things that you've read about doing, I don't know, passing through windows,
Right.
and
All
doing
these
quirky
crazy
stuff like
yeah.
that. But I do believe that ball lightning is a real thing.
Okay.
And that it's so transient. It's only there for a few seconds usually. That it's tough to have somebody, maybe with more and more people, we all have our cell phones now with
Right.
cameras. Somebody might actually capture one on their cell phones or something like that someday soon. But like you said, there's been real definitive. Here's my
Yeah.
here's my picture of Bigfoot and here's my picture of ball lightning.
There we go.
Kind of thing.
Great comparison. Exactly. So I'm still waiting. We're still waiting on the ball lightning
Yeah.
videography and photography. Now, one thing I've seen, and especially in some of these slower motion videos, bead lightning, I guess. And I'm curious about that. And it tends to be, not like it's shocking, but on the larger bolts.
He said shocking.
As it kind of fades away, you see
Right.
leftovers.
Right.
And every now and then you do, and it's like, whoa, that's kind of weird.
So there's a video on YouTube that I show students in school that shows the branching. There's a part of lightning that we do not see that comes out of the cloud, and the little fingers reach out of these clouds, and they're called step leaders or dart leaders, and they're looking for the fastest, most efficient way down to the ground. Any one of these little fingers could be that bright flash that we see, but whichever one touches, reaches, makes connection with the ground first. That's the one that gets to be that bright flash of light, and then it kind of energizes that whole, all these fingers, and that's why you have that little branching.
Right.
But that first one's got to make connection with the ground. That's what makes lightning so difficult. That's why we don't forecast lightning, because from that one point out of the cloud, you get all of these fingers going out, and any one of them could be the actual main lightning strike.
And
so that's the challenge.
It's so interesting that you say that, because there's slow motion video like online now, and sometimes it's just human nature to try to like forecast just anything in life, right? It's just probably how our survival. But you'll see, like you said, a lightning start at the top, and then sometimes it ends up over here and it goes down. I'm like, well, I didn't see that coming. And then the channel just reinforces itself once it makes contact. But yeah, it is super interesting. And I never realized in some of the high def slow motion photography how many channels there are searching. I mean, I would have thought, somebody said, there's 2 or 3, I think maybe 5, but it's just.
There's several famous pictures of lightning, one of a farmhouse in the Midwest where you can see the main lightning bolt going down into the tree, but you can see other branches and branches coming off of the house, the antenna on the house that never made that connection. So you can see that, if that had connected, it would have struck the house, but instead it struck the tree. So we have all these branches, and that's what makes lightning that challenge, because you just don't know which one's going to make that connection. But that's why we say we don't try to forecast the lightning, we forecast the thunderstorms. Where the thunderstorm's going to be. If you're in a thunderstorm, if you hear thunder, when thunder roars, you go indoors. That's what we tell people, just to be safe.
I had an experience. I only got nervous indoors during a thunderstorm one time, and it was in North Texas. And the storm was moving from the south, and the lightning core was in the front part of it. Hadn't really started raining, and the storm was moving really, really, really slow. And it was sending out these bolts, and these bolts were just cracking and banging because it was so close. It wasn't even rumbling. And I was in bed, and I remember I started to feel the hair on my legs start to stand up.
Bad sign.
Yeah, and I went, and I got out of bed, and I remember I went and I stood like in the doorway or the hallway. I wanted to put even more kind of between me and the outside because this was so slow moving and taking its time. But I remember that made me a little nervous. I was like,
almost always, if you're inside, you're safe. Because the lightning does not want to go through the air, so it's going to either choose to go through water or metal. Those are conductors of electricity. If it strikes the building that you're in, it's going to want to go through the metal pipes of the plumbing or the metal wires of the electrical system. That's what becomes the trick, because if you're inside and you're taking a shower, if you're inside doing the dishes, if you're inside playing on your Xbox or something like that, these are all things that have either you're touching metal pipes or you have things that you're holding that are plugged into the wall. Now, if you've got your Xbox with your wireless controller, that's okay. But if you're like on a laptop or anything that's plugged in, has a wire that plugs into the wall, and you're touching like that keyboard, you could get a nasty shock if that lightning were to hit your house or apartment building.
I guess corded phone deaths have gone down.
For sure, and not because people have stopped. The lightning's still there, but we just don't have corded phones anymore. But I've heard several stories about people who were on the phone that they got zapped when there was a lightning strike nearby.
Now let's go ahead and talk. I think we have a viewer question that kind of pertains to.
Yes, this one says, is it true that you are safer in your car in a lightning storm? And if so, why?
So, you want me to go ahead and grab that?
Yeah, go for it, yeah.
Because I tell people you're safer if you have to choose between being outside or in your car. Your car is much safer from lightning. And the reason, people go, well, the metal, it attracts the lightning. And there is some truth in that. And people will also tell me, I go, well, you're safe in your car. And they go, the rubber of the tires.
Right, I've heard that all the time.
And I have to break that myth. It's not the rubber of the tires.
Jump that.
Because I tell people, lightning has just passed through 2 to 3 miles of the atmosphere. 1 inch of rubber, not going to stop it, okay? And what do we do with our tires these days? We put a big steel belt in them to make them stronger, so that there's actually metal in your tires, which makes it more conductive. It is actually the metal of the car that it attracts lightning, but it also keeps you safe. It's called a Faraday cage. Dr. Faraday came up with this concept of if you're inside a metal box, the electricity, if you charge it, stays on the outside of that metal box. Now, if you're in a convertible, I can't say you're going to be protected. It's got to be an all-metal car.
Windows
or truck.
up.
Windows up. And in the old days, kids, when I had windows, I had to crank them up like this. So you wouldn't want to be cranking up your windows, even if you were like pushing. I would not touch any of the exterior, your surfaces, anything that would be connected with wires. So if you just sit there and wait for this thunderstorm to go by, even if your car is struck by lightning, you'll be safe inside the car.
Yeah. And that's one thing we've seen plenty of videos of. There was a recent video of a storm chaser. They were making a U-turn, and one storm chaser's vehicle got struck, the other one got it on camera. The guy didn't even know his vehicle had been struck.
Yeah.
And then there's some others where it kind of puts the car out of commission.
Yes.
I can't remember, there was a video I saw where it struck an SUV and
Well, with the more and more the electronics we have in cars, and even more with electric cars, which are all computer driven, a lightning strike to a car or a truck, it's probably going to become more and more problematic for vehicles.
I think about that. That's a good point. Good point. Okay, so now as we get back into this here, what are, okay, there was one, this is kind of a random. I had always heard reports of people talking about lightning on a clear day.
Yes.
Now, is this just the bolt from the blue from a distant storm, or is it, okay?
I would say that's what it is.
Okay.
You have to have a thunderstorm. You have to have that rubbing to make, it's not like lightning is just going to materialize
some
out
dust
of clear air or something like that.
Yeah.
It needs to be a consistent rubbing together of, in this case, it's ice crystals. Now we can get, people will say, well, why didn't that cloud, it's raining out of it, why didn't we get thunder out of, or lightning out of that cloud? If you look at, there's different types of clouds, and a lot of your low clouds are all liquid.
Right.
And so there's not as much of this rubbing in there, and of course water, it just doesn't build up that charge. What happens, what we watch for is we watch for a cloud that as it's getting taller and taller, it gets colder up there, and it starts to get ice crystals in the top part of it. And those ice crystals, that's what's key to getting lightning. It starts rubbing those ice crystals together. That's what will start to get you your thunderstorm. So you're going to have, days. We were talking about places that don't get a lot of lightning. Out on the West Coast, they can get days and days of rain out on the West Coast, just rain and rain and rain, no lightning, and that's because it's all kind of a warm core kind of thing where they don't have those ice crystals. In the Midwest, where the thunderstorms are, 10 miles into the atmosphere, they're very cold at the top, very warm at the bottom. That rubbing in between, that's what builds up that lightning.
And here we kind of get a mixture of both, because
sure.
every now and then we get either remnants of a tropical system or a tropical surge. I was really interesting. I saw one that had dumped between 1 to 2 inches of rain on the west side. This is years and years ago, and it was around noon, midday. It fired earlier, and I think it put down I heard maybe 2 claps of thunder.
Right.
And I went outside and I looked, and just the very tip top had some icing on it,
Right.
as far as almost like the cirrus type, but
Right.
the rest of it was it was mostly warm.
Yeah.
So yeah, the warm core processes don't lend themselves.
Yeah, you can get them. That's why if you look on hurricanes, a lot of hurricanes have either no lightning or very limited lightning. Usually you get lightning as it makes its landfall, it starts rubbing up against the land.
Oh, interesting.
You'll get lightning. But out of the ocean, they don't. You see pictures in movies of ships in these hurricanes.
Oh yeah, with all
and
this lightning.
going
Yeah,
on.
you're right.
They do get some, but not as much as you would think from a big storm that has hundreds of thunderstorms going on in it at the same time. We just don't get a lot of lightning because a hurricane is basically a big warm core kind of storm system.
And also, so that was basically the clear day kind of
Yeah.
thing. Clear day kind of thing. I just want to make mention. There was years ago a storm had kind of caught me off guard, and this is kind of, word to everybody, and that's when they say, don't be too quick to call a storm over.
Right.
I'd gone in the backyard. I think it'd been 10 minutes. The storm had drifted down to the south. This is in North Texas, in Arlington, and I was like, I hadn't heard thunder for quite a while, and then all of a sudden, boom! I mean, it had sent a bolt back miles from the storm, and I was literally shocked, for lack of a better. And I got I literally jumped up and ran inside. It was like.
Yeah, the rule of thumb is when thunder roars, go indoors. And then once you're inside, I tell people read a book. That's the safest thing to do is read a book inside. But while you're waiting, you can set a timer. I tell the students, tell Google or Alexa to set a timer for 30 minutes.
Okay.
You need to go 30 minutes without hearing thunder. And then it's safe to go outside because that thunderstorm has moved far enough away. But if you hear thunder after 10 minutes, you got to start the clock over again. So it's got to be 30 full minutes without hearing thunder because, like you said, the lightning can reach 10 miles out ahead of a thunderstorm, and it can reach 10 miles out behind that thunderstorm. Even after it's rained and it's gone by, it can still reach back like that.
Yeah, that's pretty crazy stuff. And just to go over last time, the parts of the country that see the most lightning, I think we average here like around 30 thunderstorms.
30 to 40 days a year.
With storms. And then I think Florida is like one of the hot spots.
Lightning capital of the United States is Central Florida. And because Florida's a peninsula, sticks out there between the warm waters of the Gulf of Mexico,
Sea breeze.
warm waters of the Atlantic. They've got the sea breeze coming in on both sides. And again, lift is what you need. So they clash in the middle sometimes. So parts of Central Florida see over 100 days a year, they see thunderstorms. So that's like almost 1 out of every 3 days. Versus California, Oregon, and Washington, they see less than 10 days a year of thunderstorms. And that's because of that cold California current that comes down there. It really stabilizes the atmosphere. They get rain. They can get lots of rain out there, as we saw just this last winter, but to get a vigorous kind of lift is more unusual for them. So they don't get a lot of thunderstorms out there. So they get a lot less lightning.
Yeah, and growing up in coastal California, we would wish for a thunderstorm, and there were some years we would have like 3 days a year. And I will say that one of the most incredible ones, just very quickly here, was when we had moved to North Texas. There was a storm of nearly state-sized proportions. The Anvil was about the size of Oklahoma, and this updraft was just insanely large. And I remember going outside, and it dwarfed like the house, it dwarfed everything, the whole neighborhood. It was just amazing. What I saw was little crawlers coming out from like underneath, like you have these anvil crawlers, and it was super interesting to see that. I don't know what exactly causes the individual. But it is interesting to see when you can see anvil crawlers, because they're not. How do they kind of work? I know they're in the top part of the storm.
I haven't read that much on them, but I've seen plenty of neat videos where what is happening is that we've been talking about what we call the CGs, the cloud to ground lightning bolts. But a lot of the lightning is what we call CC, cloud to cloud, or IC, in cloud lightning, and so. What it is just lightning that crawls along the bottom of the anvil. It appears to crawl along the bottom of the anvil. It's probably something about charge distribution, and it's just following that path right along the bottom of the cloud or things. But if you ever get a chance to look that up on YouTube, it looks like a little spider webs just crawling across the bottom of a thunderstorm. It's amazing.
And there's, as you said, YouTube has some wonderful videos on anvil crawlers.
Yes.
Okay, so where can people go to find out more information about lightning and lightning safety and?
So the Weather Service has a webpage dedicated to weather safety, weather.gov/safety, and there's a whole section on lightning. And I was reading it today. I was reading about some history of lightning, because lightning's been around, since the Earth's been around.
Right.
And in the 1700s, 1600s, they thought that lightning, they could ward off lightning from towns by ringing church bells.
Oh, I think I had read about that.
So what happens when a thunderstorm would approach one of these towns, they would send some poor person, go ring the church bell, and they would ring these church bells. Of course, you've got a rope, you got something sticking up high, you got a big metal thing on the top, and I think it said in the 1700s, in France alone, over 100 of these church bell ringers were struck and killed by lightning. So they decided, okay, this is not working for us. This is not. So they quit doing that. But it was a belief back in the 1700s that if you rang a church bell, it would ward off the evil spirits of the lightning and protect your town from them.
We've learned better. Just take cover yourself.
Exactly.
Well, thank you very much, Tim. It was great having you out again.
Always great to come by and
learned
chat.
a lot today. Awesome. If you enjoyed this conversation, make sure to comment, subscribe, and share it with your friends. You can check out our past archive of episodes on kfoxtv.com or listen on Spotify and Apple Podcasts. Thank you so much for breaking it down with me, and we'll see you next time here on The Breakdown.